All right, students, here we are, the last week of material. We're going to go over modules 13 and 14. I just want to go over a couple slides for each module. I don't want to take up too much of your time. I want you to really be able to focus on your final paper and prepare for the final exam. So what is artificial intelligence? You're probably familiar with this term and you've probably used it, hopefully correctly, in your day-to-day life when you're describing certain things. Now, when we talk about traditional systems, these are concerned with capturing, storing, retrieving, and working with data, your traditional databases. They just hold the information, they can display it, they can pull it up, and we can manipulate it. But AI systems, they want to generate and display knowledge and facts. How can we reproduce human thought and behavior? We're reproducing, we're mimicking. These systems don't think, they analyze, and that's a big pet peeve of me. Artificial intelligence doesn't think, it analyzes the information. It takes that and compares that with past use cases, with databases to replicate thought. We see a lot of AI being implemented into robots, and these can be very simple ones doing menial tasks around the house, such as your Roomba, maybe a lawn mowing robot. In industry, we have a lot of robots that will do tasks that are hazardous to individuals, maybe doing inspections in power plants or areas with high heat, high radiation. The robot can work there with no damage or just minimal damage to them in an environment that could be incredibly detrimental to a human. It could lead to their death. Or robots could even be doing very tedious tasks, something that a human couldn't be able to do for a full 8-hour shift. The great thing about robots is after you purchase it, it's essentially free labor. But some of the tasks they can do have to be very simple, repetitive tasks. We're not at the point where robots have enough artificial intelligence into them where they can grow and analyze situations and better adapt for it. If you have a worker on an assembly line and they're, putting together widgets, but one of the widgets isn't in the right place, or maybe the line speeds up or slows down, a human can adapt to that and change that. It's difficult at this point in time for some of these robots and some of these artificial intelligence systems to change with varying. However, some of that can be resolved with case-based reasoning. CBR is a problem-solving technique that matches new cases, problems, that assembly line that speeds up and slows down, with a previously solved case and its solution. It doesn't have to be a, a previously successful case, but think of these as past experiences. Each one of us have different past experiences. If you start a job, sometimes there will be, quote unquote, tribal knowledge. Hey, if this machine does this, we need to do these actions to rectify it. If that assembly line speeds up or slows down, this is why. This is what you can do to overcome that. CBR is the same thing, but for AI. We have all these previously stored lessons learned or cases. It's stored in a database, obviously. The system will then search for it for a similar match, maybe the exact thing or something very close, and you can have some sort of resolution based on previous experiences. You might not have heard of fuzzy logic before, and that's fine. Fuzzy logic allows computers to quote unquote reason in a way similar that you or I might. We're making approximations and vague data to produce clear and definable answers. There's an image I'm going to show in the next slide that'll make this make a little more sense. But really, we're trying to find a degree of membership in a set of data, a collection of objects. And sometimes these are very black and white objects, but a human doesn't always work in black and white or zeros and ones. So fuzzy logic is a nice transition between the way computers and humans think and express data. So temperature is one of those universal things that I think all humans can agree with. Hot is like mid 70s and above. Warm is anywhere below that. Now, obviously, there's some variation in regional areas. If you're from the South, your definition of hot is different than somebody from Maine's definition of hot. But again, these are fuzzy things. It's hard to equate a number to be hot or cold, and that's very difficult for a computer to determine if it's hot or cold. So this is where fuzzy logic kind of comes in. If you look at the hot pyramid, we're saying that the low end of quote unquote hot is 70 degrees. The high end is 100. That makes sense. 70 is hot, but it's bearable. 100 is hot. Anything above that is, sweltering. Think of all the fuzzy words that you can use to describe anything over 100 degrees. It's definitely hot, but it's more than hot. Warm, on the other hand, there's a much larger spectrum of warm. So we have some overlap. We have a gray area there, 70 to 85%. And this is where fuzzy logic comes into it. We're taking hard data, temperatures, and we're kind of bringing a human aspect into it. What is hot? What is warm? What is bearable? Module 14 is always talking about the future, emerging trends. We talk a lot about virtual reality and augmented reality. Virtual reality, this is your three-dimensional image that we create. We're building entire worlds that we can interact with. Simulations, they're immersive, they're interactive. Augmented reality is the best of reality where you're at, and combining a virtual layer on that to enhance the area you're in. I think the biggest benefit for society for virtual and augmented reality is in the training sector. We can create industry, we can create assembly lines, power plants, and have students, new workers, senior management learn and practice in a very safe and controlled environment. This brings into the cave automatic virtual environment. Think of, if you're a Star Trek fan, think of the holodeck. That's kind of what this is. It's a room with different projectors and sensors that you can immerse yourself in anything as long as you can create and design it. And this is where I'm going to end this video with a really good example of augmented reality, virtual reality, and cave. So if you read my profile, you know that I was a prior active duty submariner. I went out to sea in submarines for the Navy, and now doing the reserve, I'm still supporting the reserve component. A really great example of things that the Navy is using virtual reality is in our bridge trainer. These are released pictures. You can find these online with a whole bunch of great articles by newspapers on Navy submarine bridge trainers. This is an augmented reality room. The best way I can describe it is if you walked into an IMAX and it simulates being on the bridge of a submarine, driving in and out of different ports. It allows the crew to train. Docking a submarine is something, we don't do a whole lot. Our primary mission is going out, being undetected underwater, but we need to be able to dock. And we can do this in a very safe, controlled environment. And we can throw a whole bunch of really crazy situations to train the crew. Maybe there's a boat that's not responding to your commands or whatever. But the great thing about these trainers is it looks and feels like the real thing. So much so that some of these trainers have different quote unquote environment. They'll make it warmer or cold, or have air current to make it feel like, oh hey, I'm really going 10 knots. I can feel it on my face. This type of immersive training environment is an incredibly valuable tool that can be applied to almost any industry. The Navy's a great example. Power plants are a great example. The medical field is a great example. Even at St. Francis, in our nursing lab, we have very lifelike mannequins that are hooked up to computer systems to simulate different ailments. This hands-on training makes us better practitioners at whatever our chosen field is. Augmented reality, virtual reality, AI, this just gives this training experience so much more value. It's added benefit to the training. This is the future we live in. This is coming down the pipe right now. We're seeing a lot of applications in the world already. I hope that you can take some of this back to your industry or your future industry. We're going to end this video here and walk into the last week of the course. As always, if you have any questions, reach out to me. Please, please, please put some time into your final paper. Get ready for your final exam. Best of luck to all of you.